Welcome to the Rise of the Ageless Starman. If you are an investor, a scientist, or an entrepreneur, please join us as we discuss about today's innovation and tomorrow's creation. Together we are here to find out how to make humans creative and vital at any age. Hello everyone to the Rise of the Ageless Starman. Today I'm hosting the rockstar of the longevity science, Aubry the Grey. Aubry pioneered the field of longevity and cracked the convention that we cannot do anything about aging with science. Today, his approach to the biology of aging started to get accepted both in academia and the industry. He's the chief science officer of the SENS Foundation, and if you want to start your journey as an investor or as an entrepreneur or a scientist, he is the guy that will show you the way. Aubry, first of all, thank you for joining to my podcast.
It's my pleasure. Thank you for having me.
Yeah, it's a little bit crazy days, but we must keep the conversation of aging going. Even the corona stole the show, which leads me to the first question. How do you think that it affected the longevity industry?
Well, it's probably going to affect the longevity industry and indeed the whole longevity crusade at least as much as it's going to affect everything else, because everyone is being more careful about investment. Laboratory experiments are not being done because labs are closed. It's going to slow a lot of things down.
Yeah, it looks like this, but on the other hand, like what I feel that everybody in the biotech started to work on it. So maybe it shows that if there's a real motive and the topic gets to everyone, then everybody is working on the problem, and maybe it will teach us to how to work on other problems like aging.
Maybe. I mean, I think it's going to be very important to see what happens as we pull out of this crisis in terms of what lessons are learned and how they are learned. It may be that we come out of it knowing that we need to maintain a greater degree of preparedness for future pandemics. And that's great, because certainly it has been an absolute scandal for decades how little investment has been going into the development of new vaccines against, for example, multi-drug resistant bacteria. I think that could work out really well, that there will be much more preparedness and an improvement in the speed at which vaccines are tested and distributed for new infections. That's all great. In terms of our own work on the biology of aging, it's more uncertain. What I would like to see is that the work that we have done and other people have done on trying to rejuvenate the immune system of the elderly would be ramped up. There would be more investment in that, both public and private investment, because, of course, the elderly are particularly badly affected in the case of the coronavirus, even though, of course, they are more vulnerable to most infections. It's particularly extreme in this case. So that may help as well. And certainly there has been plenty of progress over the past few years in rejuvenating the immune system. So there is plenty of starting point to be optimistic from. However, what I'd like to see, of course, is an understanding that the major health problem in the world today is aging. That, the total number of people that have died of coronavirus so far is about the same number that die of aging in about 5 hours worldwide. So we've still got to get that message through. And I don't know whether that's necessarily going to get any easier as a result of this.
Yes, I'm glad you touched the elderly population and how they are affected now from the coronavirus. Because when I, when I started the podcast, I saw on the Alzheimer Association website the numbers that will be in 2015. They say only in the US there will be 14 million patients of Alzheimer, which is more than Michigan and South Carolina together right now. What is frightening is that it can shut down a health system exactly like we saw in the coronavirus now in Italy. And then we are getting to a vicious circle where we don't have a treatment and we need to spend resources to take care of them instead of creating therapies. And this is why I think it is so important to prevent it before, as you said.
Yep, that's right. I mean, the case of Alzheimer's, of course, is not new in the sense that everybody has been aware for a long time that the epidemic of Alzheimer's is growing and growing and is on track to completely demolish and make bankrupt the healthcare systems of the industrialized world. So something has to be done. But the difficulty that has always existed in the case of Alzheimer's disease is rather the same as for aging overall. Namely, people have been unconvinced that anything can be done, even if the investment is improved. Again, we need progress in the laboratory. We need improved results, preliminary results, in order to change that, in order to give people more confidence that something might actually be possible as a result of it. Now, funding for Alzheimer's disease is already pretty good, but it's not necessarily targeted in the right way. A lot of it is involved in trying to slow down the rate at which damage accumulates in the brain, which hasn't really got anywhere. And not nearly enough work is being done to repair brains that have already accumulated a lot of damage.
Your approach was a little bit different. Today, the mainstream is starting like to accept, starting to accept and move this direction. Can you explain a little bit in a nutshell?
Actually, from the point of view of scientists working on the biology of aging, the approach that I introduced about 20 years ago now was actually not a little bit different. It was completely different from what everybody else was thinking. Everybody else back then was thinking in terms of the only way we could possibly postpone the health problems of late life would be by making the body somehow run more cleanly and generate less damage to itself as a consequence of its normal operation. And people were very pessimistic because they weren't getting anywhere in actually making that happen. And indeed, I think that was correct. That's really infeasible approach. It's not an approach that's got any real chance of getting anywhere significant anytime soon. But what I did, I introduced the idea that maybe we don't need to do that. Maybe we can actually let the body damage itself at the normal rate, and instead we can postpone the health problems of late life by actually repairing the damage after it's been created. The idea, of course, there is that the damage creation is not the problem. It's the amount of damage that exists that's the problem. So you'd achieve the same thing, and maybe it'll be easier to do because it won't involve actually interfering in the way that metabolism works. Furthermore, it's exactly the way that we already successfully extend the longevity of simple machines like cars. So, just preventative maintenance. So this idea, as I say, was very different, and it took maybe 10 years for the community to really take it seriously and see that it made some kind of scientific sense. But over the past 10 years, it's been a very, very straightforward, mainstream, orthodox idea. It's been reinvented by other people. It's definitely a thing now.
Yeah. And like when you talk about it, like it's like a machine, and and we need to rejuvenate it. I think maybe when we budget, I did a little research about a professor named Michal Schwartz. You heard about her?
No.
She has an advanced Alzheimer research, and what she said in the beginning that she didn't say I want to cure Alzheimer. I wanted to know how the immune system and the nerve system are having a connection, how they connect. And from that on, it led her to go to research, to Alzheimer research, and now she's very advanced. She's someone to follow. But I'm trying to think about it, that if maybe from the beginning she would say I want to go to cure Alzheimer, she would start to read about the convention in the Alzheimer research, and she wouldn't get to that kind of question like she solved. And maybe when we budget, we don't need to define it as diseases like cancer or Alzheimer. Maybe we need to know what questions we want to solve. It's a lot more clear. It has clearness, I think.
Yeah, I kind of agree. I mean, essentially what you're trying to say is that there is the wrong kind of classification going on in medical research and medical care. And that's certainly true. For example, at the moment, we think of certain aspects of aging as diseases, things like Alzheimer's or almost all cancers, etc., and certain aspects of aging as somehow aging itself outside of disease. And that's completely wrong. There's no biological basis for that distinction whatsoever. And it makes people focus on the wrong problems and the wrong potential solutions. In America, for example, the research funding from the government for health problems of late life is split up along the lines I just described. And that means that a lot of work that could be very valuable and very important for making progress against these health problems is just not funded because it kind of crosses these boundaries, these artificial boundaries that have been created.
You're a programmer at your core, a software guy. I have a few thoughts about it. First of all, we've been said that DNA is like the code of life. And if it's like this, then why is it so hard to do reverse engineering and fix a lot of the problems if it's code? And why are we...
So from a programmer's point of view, it's easy to explain that. The reason why it's so hard to reverse engineer genetic code is because our genetic code is spaghetti code, which is not written in a structured way, and moreover, it's not commented. There is no English explanation of it written down. So so it's like trying to reverse engineer machine code that somebody wrote. It's extremely difficult. But it's worse than that. The code doesn't even need to be reverse engineered in order to get the goal that we require, namely keeping people healthy late in life, because the problem is the code that's not there. We have gaps in our automatic built-in damage repair machinery, and the approach that will keep us healthy for longer is to add code, not to alter the code that we already have.
I did not expect that answer. That we need to add the code. But isn't it depend on what problem it is?
Not really. You see, a long time ago, a century ago, people used to think that aging exists on purpose. In other words, that we have genes that make us age, and that the attempt to try to make us live longer in a healthy state is some kind of fight against what against what we have in our genes. But that's not true at all. But back in the 1950s or so, people started to understand that actually the body is already really good at not aging, and we just need to make it a bit better. In other words, we and our genome are on the same side.
Okay. And many times, like for AI experts and data scientists, software guys, I talk with a lot of my guests about this problem, that edtech and or gaming or cybersecurity it's a lot more easier to pull those talented guys over there because the results are very fast and it's easier for investor to invest in such a startup, and we lose a lot of talented people this way.
Yeah.
What can we show people that will pull them?
Excuse me. Yeah, you're absolutely right. The areas of technology in which results can be obtained quickly have always been much easier to obtain investment for. But over time, more and more investors understand that this is an opportunity. In other words, the best way to make money as an investor is to invest in areas that are not so well understood by most other investors, right? So that you have a less crowded market, so to speak. And now more and more investors are getting into really early stage stuff, understanding that it's okay to have to wait a long time before you actually get a profit, and eventually you will get much more much more profit in the long run, so long as you're willing to take that, to be patient. The investors that I work with all the time are exactly like that. They are people who perhaps have quite a lot of resources, so they can afford to wait a long time before they make money, and they understand that this is the real way to go because the amount of money they will make in the end is far more than they could make in the near term in other sectors.
Yeah, it's and it's the only sector that will give you profit of the time you last.
Well, that's also true, certainly. I mean, a number of investors, and indeed a number of our donors who come to the charity, SENS Research Foundation, are doing it because they want to extend their own healthy life. Now, I don't actually think that that's a very sensible reason to do it, because the probability that you will benefit this way is rather low. It just depends on whether you are just at the cusp, whether you will make the cut or not. But that's okay. People can donate or invest for any reason.
I'll stay in the issue of AI. I had a question from one of your followers, Chris McCauley. What he asked is, what impact do you think AI will have on the development of rejuvenation therapies? And the second question he asked was, assuming we succeed, what is the most optimal and realistic scenario for how we could rejuvenate our bodies? How fast could it be done?
All right. So I'll do the artificial intelligence question first. The direct impact of artificial intelligence on the development of these therapies is already quite clear. There are some successful companies, such as, for example, the company that I work closely with called In Silico Medicine, which are using state-of-the-art machine learning techniques to develop new drugs or to identify new applications for existing drugs for age-related purposes. And they have already shown some very impressive results. That will only improve over time. There are these approaches are mainly focused on developing new pharmaceutical interventions, and that will never be the whole story for keeping people healthy late in life, but it's still an important part of it. So that's one important thing. There is actually, however, another more indirect impact of artificial intelligence on this crusade, which is perhaps a little bit strange, but it's very important, namely that it will improve the amount of automation in the economy in general. It will replace a lot of jobs, in fact, most of the jobs that exist today. And that means that we will develop a completely new way of distributing wealth that does not rely on everybody having a job, everybody between the ages of, let's say, 20 and 70, which is the way we are today. So that's a good thing, because it will eliminate or address some of the reservations that people have, some of the concerns that people have with regard to how a post-aging world would work. People say things like, oh dear, how will we pay the pensions if everyone's living a long time? But pensions won't be a thing anymore, because, the world will be structured in a completely different way. You're going to have to tell me again what Chris's second question was.
Okay, the second question was, assuming we succeed, what is the most optimal and realistic scenario for how we could rejuvenate our bodies, and how fast could it be done? Would it be an ongoing repair process with nanotechnology or something else?
I don't think that nanotechnology is going to play a particularly significant role. It may do so in the long term, in the distant future. But for the moment, I think it's going to be more boring than that. We're just going to do things that you've already heard about that already somewhat work, like stem cell therapies and gene therapies. The impact once we've got this developed will be complete. In other words, people will be truly as functional, both mentally and physically, however long ago they were born, as they were when they were in their 20s or 30s. So there is no real limit to that. People will look just like that, they will feel just like that, and they will function just like that.
Okay, I wish. Sounds good until now. Everything you described the future.
It will definitely happen. The only question is how soon it will happen, and that's what we have to focus on now.
Yeah. So it's good you mentioned that, because my next question was, what do we have like in the industry of technologies that are helping us with drug development process? Now it's very expensive and long. I saw one project, organ on a chip, in the Wyss institution, which what they write on their website will help drug development in the future. But what else can we do?
Well, I think honestly, a lot of what we need to do is not at the level of the science, but at the level of the regulation of such drugs. Many years ago, I wrote an editorial about the whole way in which the medical industry works and how new treatments are disseminated. And basically I said, listen, we need to be more sophisticated about the risk-benefit ratio. There is a very central principle in medical care today, worldwide, which basically says, do no harm. In other words, it's far, far more important to avoid any kind of harm to a patient than it is to cure them. And, that made sense when medicine was complete black magic and you could simply not have any idea what was going to happen. But now that we have a much more rational corpus of information about medicine and about experimental medicine, maybe we ought to take a more nuanced approach. And I think that one consequence of the current crisis over coronavirus is that that may actually happen, that we may actually start to see, for example, accelerated release of vaccines. Already we've seen that the first vaccine to be tested in humans is already in human testing. The reason it is because they just didn't do any animal testing. They just developed the vaccine and went straight to humans. And now the question is, how long will the human testing take? People are still saying that it could be several months before the vaccine is approved for general use. And that's too long. Something's got to be done to change that.
Yeah, I think they said even the fast track will take. I just saw an article yesterday, but I think it's at least 1 year, even fast track.
That's right.
Another question from one of your followers is Andrew Richard McCree. Okay. What he asked is, he asked if there's something that actually is in human and animal trials that started already.
Absolutely. So, of course, the damage repair approach is a divide and conquer approach. We have to develop a lot of different systems to address different types of damage. And some of those therapies are easier to develop than others. So the result is that some of them are already in clinical trials. We have clinical trials for cell therapy against Parkinson's disease, for example. And we also have therapies in clinical trials to eliminate senescent cells. And those trials are going really well. Other areas, like, for example, the removal of waste products inside cells in the artery and in the eye, are moving into clinical trials this year, probably. And also for removing amyloid, as I said, that's already been done in the brain, and we are doing it in other tissues. So this is all great. There are some areas that are not quite so far along, though, and where it might take another 2 or 3 years before we start clinical trials. And eventually, when we've got them all working, we need to combine them. We need to actually apply all of these therapies to the same people at the same time, and that's likely to take another number of years to get it right. So it's still a little way to go, but everything's going pretty nicely.
Okay. One more question from the followers. NRF1, NRF2, and NED. Are these pathways to genetic expression relevant to life extension?
Yes, they're relevant, but they are not our main focus. So essentially everything that involves changing gene expression over a whole body or even one organ involves trying to slow down the rate at which damage is generated by that organ or by the body. And that's great, but there's only a limit to how much you can achieve that way. It's much better if you can repair the damage that's already accumulated, which is our focus.
And you described in the beginning how Corona affects the investor these days, but before the Corona what was the difference in terms of the investors like 10 years ago than today?
Oh, an enormous difference. In fact, even if we compare, 3 months ago with 5 years ago, a huge difference. Basically, the difference comes from the fact that initially a very small number of investors started to realize that the progress that was occurring in the laboratory was sufficient to justify confidence that eventually there would be products that would really work and would really, make people healthier late in life. And as I said earlier, these are investors who are happy to take a long time before they make a profit. And that's what happened. We were able to get investors to put money into projects. We ourselves at SENS Research Foundation were able to spin out a number of our projects as startup companies. But more importantly, there was a lot of other companies that emerged doing the same kind of thing, and they also got investment. And over the past couple of years, there's been this really sharp exponential rise in the number of investors. People come to me all the time saying, I'm an investor, I'm new to this space, I don't know what to do, I would like to be connected with a network that can help me to pick the right investment. And I make introductions every day.
You've been in Israel?
I've been in Israel a few times, yes.
Is there something going on here, or we're still asleep?
Oh, there's lots going on. First of all, there's really good science. There are some groups that have been doing great science in academia in Israel for a long time. And there are also now emerging companies. You mentioned artificial intelligence before. That's a very strong area for Israel. But also on the investment side. So some of the wealthiest people in Israel are getting heavily involved in investing in this space.
Yeah. Actually, I've been in a Gero science conference in September. It was really a serious one, and I hope they will do next year too.
Yeah.
And maybe you will come.
Maybe.
Okay, thank you, Aubry. It was
Bye.
Interesting. Bye. I hope you enjoyed this episode with Aubry. As he mentioned during our episode, AI in Israel is a well-developed industry. So if you want to hear more about AI in Israel, I invite you to listen to the episode before with Amir Armati from Spark Beyond. Spark Beyond is a very innovative data-driven startup in Israel, and these days they consult governments how to fight coronavirus. So don't miss